a viscous lava dome began growing in 1922. Known as Santiaguito, this lava dome complex has been growing ever since, continuously erupting for 102 years straight and counting. Yet, you might be surprised to learn that despite the complete lack of any pauses at this growing lava dome, the lava it is erupting today is not the same lava that it erupted a century ago. They are quite compositionally different, creating a fascinating story on how and why this composition change occurred. This change in composition has caused the associated hazards tush diagram and explosivity of the volcano to change over time, which is why it is important to understand. Before I explain what I mean, I want to briefly help everyone understand the tush diagram or total alkali silica diagram, which is what scientists use to plot the composition of erupted material from a volcano. Compositions can tell us not only about why and how a volcano formed, but also the nature of the hazards it is likely to produce. Thus, I have labeled a Holocene active volcano that typically erupts a lava composition characteristic of each of these categories. In the case of the now more than century-old Santiaguito lava dome complex, when it first began to grow it erupted distinctively dacite lava which had a viscosity 30 million times higher than that of water and a temperature of approximately 870 degrees Celsius. However, today, what erupts from the Santiaguito dome is not dacite but instead andesite. This andesite has a viscosity 6 times lower and erupts at a temperature of 940 degrees Celsius. This composition change has been constant in between these two timeframes as the lavas that erupted became less alkali-rich, less silica-rich, and higher temperature over time. Largely due to this fact, primarily the lower viscosity over time, more gas has been able to escape instead of becoming trapped underneath the lava, meaning that eruptions as a whole have gotten ever so slightly less explosive as the years progress. At the same time, the lava domes which have formed have gotten less steep over time, and due to the lower viscosity lava, sometimes now even distinctive lava lobes flow up to 4 kilometers away instead of building a massive lava dome above the actively erupting vent. This change in lava and thus magma composition is all owed to a process known as fractional crystallization. You see, the Santa Maria volcano as a whole, despite its recent eruptive activity, is largely composed of basaltic andesite lava rock, which is not very evolved. Underground bodies of fractional crystallization magma can remain in a partially molten state for tens of thousands of years or more. Yet, this material does slowly cool over time, and as it does cool, the higher temperature minerals that are poor in silica crystallize out of solution in a process known as fractional crystallization, causing the magma to change in composition to slowly become more silica-rich over time and creating more viscous batches of magma on top of one another. When Santa Maria produced draining magma, its powerful 1902 eruption, it erupted its most viscous dacite magma, which happened to be at the top of its existing magma chamber, thus removing it. This allowed for less silica-rich but still dacite magma to begin continuously yurting in 1922. However, once large portions of the eruptible dacite magma had been removed, what remained was high silica andesite magma, which is what is being erupted at the present. Although this has not happened yet, we are likely to one day see basaltic andesite lava begin erupting from the Santiaguito lava. Future activity? Dome complex. This could very well vastly change the nature of the eruption, potentially creating lava fountains, strombolian activity, and perhaps even starting to build a secondary stratocone. As a final note, I would like to thank my new patron Don Keithley